All right, let's get excited about accelerated motion graphs. Yay! It's going to be so much fun. Okay, so before we start on accelerated motion graphs, I do want to take a second and review constant motion graphs. All right, so with our constant motion graphs, I want you to draw this position versus time graph. All right, so we're going to have this, and then this, and then this. Okay, so if you are looking at that position versus time graph, we should be able to see these and be able to tell so much about them. All right, but the one thing that I really want you to see right now is that we have 3 different segments of motion. So in those 3 different segments of motion, we have 3 different motions happening. All right, so we'll call this one segment A, this one segment B, and then this one segment C. All right, so in segment A, you see that we have a straight diagonal line, all right, that's going in the positive direction. So that straight diagonal line in the positive direction means that we have a constant positive velocity. We have a constant positive velocity. All right, then if we look at part B, we see a horizontal line. All right, a horizontal line on a position versus time graph means no motion. You have something that is at rest. And then C, all right, this is a big part right here is a big deal. So what we have done is we have gone from a positive direction. Now we are going into a negative slope. So at this point right here, we have changed our direction. We have changed our direction. So now, C, we have a negative slope. So that means we're going in the negative direction. But we also see that we are moving at a constant velocity. But another thing that should be popping out is that this slope is less steep than A. All right, so we should see that we have a slower, constant, negative velocity, all right, than our positive velocity. All right, so what we're going to do is we are going to take those 3 segments and we are going to create a velocity versus time graph for that. All right, so we have time on our x-axis, velocity on our y. All right, this means that our velocity is 0 at that point. Then we have our positive, and then we have our negative. All right, so if we are trying to figure out what we're doing, all right, that first segment, we know we have a constant positive velocity. All right, so a constant velocity is shown as a straight horizontal line. If it's positive, that means that it's going to be above that x-axis. So here we have point A, a constant positive velocity. All right, that B, that segment B, we have something that is at rest. All right, we know that the slope of a horizontal line is 0. So we also know that the velocity of something at rest is 0. All right, so here we have B, our segment B. And then last but not least, we are looking at C. That is a slower constant negative velocity. Again, we show a constant velocity as a straight horizontal line. If it's a negative velocity, that means that it's going to be below that x-axis. And if it's slower than what A was going, that just means that it's going to be closer to that x-axis. All right, so here we have our velocity versus time graph for those segments. All right, now, because we know that the slope of a position versus time graph gives us velocity, we were able to take those slopes and create that velocity versus time graphs. We also know that the slope of a velocity versus time graph gives us acceleration. All right, so we can take our velocity versus time graph and turn it into an acceleration versus time graph. All right, acceleration versus time graphs are set up exactly how velocity versus time graphs are. So we have 0, plus, and minus. All right, so if we are looking at all of those, notice what every single one of those are. All right, A is a horizontal line. B is a horizontal line. C is a horizontal line. It doesn't matter that A and C are both moving. They're moving at constant motion because this is a constant motion graph. All right, and we should know by now that constant motion means that we do not have any acceleration. And the slope of all three of these horizontal lines is 0. All right, so if we were to create an acceleration versus time graph for that, they would just all be at 0. All right, so that's what that would look like. All right, so we're going to kind of change it up a little bit. All right, with our lab from last week, the Ramp It Up lab, we saw that things don't always travel at a constant velocity. All right, in our lab, we saw that as the car went down the ramp, it sped up. All right, so speeding up is a type of acceleration. And this is just your reminder. All right, there are 3 ways to have acceleration. We can be speeding up, we can be slowing down, or because acceleration is the change in velocity over time. Because velocity is a vector quantity, that means that it has direction. So if we also change direction, that is also a type of acceleration. So we can either be speeding up, slowing down, or changing direction, and all of that means that we have acceleration. So on that lab, you should have seen a graph that looked something similar to this. All right, so now because we have these accelerating motion or accelerated motion scenarios, we are no longer just looking at these straight diagonal and straight horizontal lines on position versus time graphs. We are also looking at curved motion. All right, if you see curved motion on a position versus time graph, that should automatically tell you that we have some type of acceleration. All right, so just like we saw in our lab, all right, most objects don't necessarily move at a constant velocity. All right, even if they are moving at a constant velocity, in order for them to change to another constant velocity, it's not going to happen instantaneously. All right, sometimes they're going to have to either slow down to get to another constant velocity or speed up to get to another constant velocity. So graphs like this one, all right, graphs like this one are not necessarily real life. We don't just go straight from a constant velocity, straight to 0, straight to another constant velocity. All right, most of the time, or all the time, we do have to speed up or slow down. All right, so that's what we're going to be looking at. All right, so if we have these curves on our position versus time graphs, that means that we no longer have constant velocity. All right, so this is what we have been seeing, these straight horizontal lines. A straight horizontal line means constant velocity, means that there is no acceleration. All right, but we know that most of the time we do have some type of acceleration. All right, so I want you to look at these next 3, technically 4, because we're going to draw an extra one. All right, so if we are looking at this one, so remember that this is 0, this is plus, this is minus. All right, so remember on our last set of notes, I got you to draw out a chart that had both the signs for velocity and acceleration. And whenever we combine those, we can only then, whenever we look at both the signs for velocity and for acceleration, only then can we interpret the motion that's occurring. All right, so if we are looking at this one, all right, so we know that it has positive velocity because it is above that x-axis. All right, we also know that it has a positive slope, which means it has a positive acceleration. So whenever we have a positive velocity and a positive acceleration, these are like signs. That means that we are speeding up. Whenever we have those like signs, that means that we are speeding up. Now, if I want to figure out what direction I'm speeding up in, I have to look at the sign for the velocity. So because I have a positive velocity, that tells me that I am speeding up in the positive direction. That is speeding up in the positive direction. Now, another way for you to look at it, if you didn't want to have to figure out, okay, the sign for velocity is positive, the sign for acceleration is also positive, that means that we're speeding up. All right, you can just look at what this graph is doing. All right, so this x-axis right here, hopefully this will go over. There we go. This x-axis is 0 velocity. And if we look at our line, that line is trending away from that x-axis. So it's going away from 0. So if you're going away from 0, that also tells you that you are speeding up. If your line is going away from 0, you should know that you're speeding up. All right, if we look at this one, all right, we know we are above that x-axis, so we have a positive velocity. All right, if we look at it, we have a negative slope. That means that we have a negative acceleration. Well, over here, we had like signs that meant that we were speeding up. Now we have opposite signs, and we know that opposite signs means that we are slowing down. Again, if we want to figure out what direction we're slowing down in, we look at the sign for the velocity. So it is positive. It's still above that x-axis. So we know we're slowing down, but we're slowing down in the positive direction. All right, we're slowing down in the positive direction. And again, if you don't want to have to figure out, okay, velocity is positive, acceleration is negative, we have opposite signs, that means that I'm slowing down, you can look at what your line is doing. Again, this x-axis is our 0 meters per second. And if we look at our line is trending towards that x-axis. So it's trending towards 0. So if our line is going towards 0, that means that we are slowing down. If our line is trending towards 0, that means we're slowing down. All right, now this one's a little bit of a change because this one, we are now below that x-axis, which means we have a negative velocity. And if we're looking at our slope, that means we have a negative slope. So a negative slope on velocity versus time graph does mean that we have negative acceleration. So we have negative velocity, negative acceleration. We have those signs that are the same. We have like signs, and that means that we are speeding up. Like signs means that we're speeding up. So we saw two positives over here. That meant that we were speeding up. Two negatives also means that we're speeding up. But instead of speeding up in the positive direction, we are speeding up in the negative direction here. Okay, and again, if you didn't want to have to think about it, like negative velocity, negative acceleration, like signs means speeding up, we can look at what our line is doing. So we have that 0, Our x-axis is 0, and our line is trending away from 0. So if our line is trending away from 0, that means that we are speeding up. Our line is trending away from 0, so that means that we are speeding up. All right, I want you to draw one last velocity versus time graph. All right, so we're going to create it, time. I don't know why I didn't put it on here, but it's fine. We'll just draw it. Okay, so same setup. But this time, it's going to be like this. Okay, so we're going to have that. All right, so the first thing that I want you to see is what our sign for our velocity is. So we see it, it's below that x-axis, so we know that we have a negative velocity. All right, we are also looking at a positive slope, so that means that we have a positive acceleration. All right, we had like signs on this one that meant speeding up. We have opposite signs here, so that tells us that we are slowing down. Those like signs mean that I'm slowing down. All right, but if I'm trying to figure out what direction I'm going in, I have to look at the direction for the velocity. It's below that 0, negative velocity. So I'm slowing down in the negative direction. Again, if I don't want to have to think that hard about it, remember that this is 0. My line is trending towards 0. It's trending towards 0. So if your line is going towards 0, that means that you are slowing down. Slowing down. All right, so if we look at all 4 of these, all right, I want you to see some similarities and some differences. All right, so right here and right here, we have negative slopes. That means that we have negative accelerations. But here, that negative slope meant that I was slowing down. Right here, that negative slope or negative acceleration meant that I was speeding up. So once again, we cannot just look at the sign for acceleration and say, oh, that positive acceleration automatically means that we're speeding up, or oh, that negative acceleration means that we're automatically slowing down. No, you have to compare the sign for acceleration and the sign for velocity in order to figure out what is truly happening. And it's the same thing with these. We have a positive slope right here and a positive slope right here. But this one, we're speeding up. This one, we're slowing down. Okay, so I want you to just have that in the back of your mind. You cannot just look at the sign for acceleration and be able to tell if it's speeding up or slowing down. All right, so let's look at these 2 graphs. All right, so they look similar, but they're not. All right, but we want to be able to describe the motion, interpret what's happening on each of these. All right, so below each of these, I want you to put A, B, and C. We're going to describe the motion that's happening in each of these. All right, so if we're looking at graph 1, this will be graph 1, this will be graph 2. All right, so if we're looking at graph 1, look at A. What type of line do you see on or for segment A? Hopefully, your brain is processing that we see a straight horizontal line that is above 0. A straight horizontal line above 0 means that I have a constant positive velocity. That means that I have a constant positive velocity. All right, now for B is definitely not constant. B means that I have changing velocity. All right, so we can do this one of two ways. We can look and see that we're in the positive velocity, but our slope for B is negative, and that tells us that we have opposite signs, which means that we're slowing down. We could also just see where B is trending. We see that it's trending towards our 0 meters per second. So that means that it is slowing down. Now, it is not changing direction because it's still above that 0. So we're slowing down in that positive direction. Slowing down in the positive direction. And then C is another straight horizontal line above 0. So we have another constant positive velocity, but hopefully you can tell the difference between A and C, and that is that C is closer to 0 than A is. So that means that C is a slower constant positive velocity. It is a slower constant positive velocity. All right, so we have those two straight horizontal lines. That tells us that we have constant velocity. This tells us that we have some sort of acceleration. All right, look at graph 2. All right, so we have a straight diagonal line that is trending toward 0. All right, so hopefully you are saying, or you are realizing that because it is trending towards 0, that means that it is slowing down. Now, it is still above 0, so it's still in that positive direction, so it's slowing down in the positive direction. Now, B is a straight horizontal line on 0. So if something is on 0, that means that it's not moving. It is at rest. Now, this point right here is super duper important. All right, what we have done is we have crossed over that x-axis on a velocity versus time graph. If you ever cross over the x-axis on a velocity versus time graph, that means that you have gone from the positive direction into the negative direction. So that means that you have changed your direction. If you ever have that crossover between or from positive to negative, that means that you have changed your direction. So C, we have that negative slope just like we did with A, but our line is trending away from 0. That line is trending away from 0. So a negative velocity, negative slope does mean that we are speeding up, but this time we are in the negative direction. Okay. All right. So I hope that you are starting to get the hang of interpreting these graphs that don't have constant velocity. We're going to keep moving though. All right. So with this example, I've given you a scenario and I want you to sketch a position versus time graph, then a velocity versus time graph, and then I want you to turn it into an acceleration versus time graph from it. All right, so again, we are still only dealing with one-dimensional motion. All right, so whenever I say that we are hitting a golf ball, I'm not talking about the change in its vertical motion. I'm only talking about the horizontal motion here. All right, so whenever you hit a golf ball, it travels through the air at 25 meters per second. Now, that means that while it's in the air, it's going at a constant 25 meters per second. All right, then it's going to decelerate once it hits the ground 100 meters away until it comes to a stop at 110 meters away. All right, so if I want you to create this position versus time graph, the first thing that you need to realize is that you are going to have 3 different segments of motion. All right, so we have our time and then our position So we have 3 different segments of motion. So we're going to do these in different colors. All right, our first segment is a constant motion, a constant velocity of 25 meters per second. All right, so we would see that constant motion as a straight diagonal line. It is a straight diagonal line until it gets to that 100 meter mark. All right, at that 100 meter mark, it says that it decelerates. Decelerates is another name for slows down. Now, it did not say that it changed direction. It just said that it slowed down. So we're still going in the positive direction. We're just going from a faster speed to a slower speed. So that means that we're going to have some kind of curve. All right, so for that curve, because it is slowing down, we know that it is going to go from more steep to less steep. More steep to less steep until it reaches that 110 meter mark, where it does say that it is going to stop. And we know that an object at rest is just a straight horizontal line. All right, so we have those 3 different segments. So we're going to turn those 3 segments into a velocity versus time graph. I only need the top portion of this because it does not ever change direction and go in the negative. All right, but I always do like to put a little bit of that negative in there. All right, so if we're doing this piece by piece, that first piece is a straight diagonal line, which is a constant velocity. It is a constant velocity of positive 25 meters per second. So up here at the positive 25 meter per second mark, we would have a straight horizontal line. A straight horizontal line at 25 meters per second. That tells us that we have a constant velocity of 25 meters per second. All right, now that curve, that green curve, tells us that we slow down. We're still going in the positive direction, but we are slowing down. So the way that we show that is we have a straight diagonal line that is trending toward 0. It's trending toward 0. And then it stops. All right, so we show a stopped line that is a horizontal line which has no slope, which is a horizontal line on 0 because the velocity of something at rest is 0. So that would be our velocity versus time. Now we know that the slope of a velocity versus time graph does give us acceleration versus time. And we're going to label or set up. There we go. Set up our acceleration versus time graphs the exact same way we do our velocity versus time graphs. So we have plus up here, 0 right here, negative down here. All right, so that first one is a constant velocity. All right, hopefully you know by now that if you are going at a constant velocity, that means that you have no acceleration. If you don't know that by now, the slope of a horizontal line is 0. All right, so that's where we get that horizontal line on 0. Now that green segment is a straight diagonal line. Okay, we have a straight diagonal line, which means a constant slope. So we have a constant acceleration. It's a negative slope, so that tells us that we have a constant negative acceleration. So that's how we would show a constant negative acceleration. And then if we are not moving, again, we have that horizontal line. The slope of a horizontal line is 0. So we have no acceleration for that part either. Okay, So the only difference between what we have been doing with constant motion and what we're doing now is that we have now added constant acceleration. Now in CP, we will never, ever, ever deal with non-constant acceleration. All right, so you're either going to see a horizontal line on 0. So that means that we have no acceleration. So that is either a constant velocity or no motion whatsoever. Or we're going to see a horizontal line either above 0 or below 0. And those horizontal lines above or below do mean that we have constant acceleration. We have constant acceleration. Now, one thing that you do need to remember is that constant acceleration is not the same as constant velocity. It is not the same as constant velocity. A lot of you continue to get that kind of misconstrued. All right, so constant acceleration is not the same as constant velocity. Constant acceleration just means that our velocity is changing at a constant rate. All right, it's not constant velocity. It just means that our velocity is changing at a constant rate. All right, so for these, I love these 3 graphs because these are going to be what you're going to see a lot of the time. So I'm going to either on a test or on a worksheet or something like that, I'm going to give you a position versus time graph, and you're going to have to create a velocity versus time graph, or an acceleration an acceleration versus time graph, or I will give you the velocity versus time graph and you will have to create a position and an acceleration versus time graph. All right, so the easiest way to do that is to line them up vertically and then to draw these. Do you see these green dash vertical lines? All right, you don't have those on your paper, so I want you to draw those on your paper right now. All those are doing are just separating your segments of motion, okay? So we're going to have 4 different segments of motion. So we're going to label these. So this first segment is going to be A, this one will be B, then we have C, then we have D. Okay, so for me, what I like to do first is I like to interpret the position versus time graphs first, all right, in order to be able to tell what's happening. All right, so if we look at just that yellow line, all right, we're just looking at the yellow graph. That's our position versus time graphs. We do not see any straight diagonal or straight horizontal lines. All right, that tells us that we do not have any sort of constant motion happening. There is no constant motion happening. Sorry, I don't know how to get off that. All right, so there's no constant motion happening. So we have all types of acceleration happening. All right, so let's look at that first part. All right, so segment A of our yellow graph, our position versus time graph. All right, so if we look at it, we should be able to see that we have a positive slope. All right, that positive slope means that we have a positive velocity. All right, that means that it's going in the positive direction. Now, we know it's either going to be speeding up or slowing down, so that's the next part. We have to figure out, is this speeding up or is it slowing down? So if we are looking at that line, we have to look at what the slopes are doing. So if you look at this very carefully, you should see that it goes from a less steep slope to a more steep slope. So less steep to more steep means that I am speeding up. So for this part A, this segment A, I am speeding up in the positive direction. I am speeding up in the positive direction. So that comes from the positive slope and then the less steep to more steep. So if I wanted to turn that into a velocity versus time graph, first of all, I'm going to look at the positive direction. That positive direction means that my line is going to be above 0. And if I'm speeding up, my line is going to be going away from 0. It's going to be trending away from 0. So that's exactly what we see right there. All right, so we have that straight diagonal line that's going in the positive direction. We know that the slope of a velocity versus time graph does give us acceleration. So this is a positive slope. That means that we have a positive acceleration. So we have a constant positive acceleration, which is exactly what we see right here. That constant positive acceleration means that my object is speeding up at a constant rate. All right, so let's look at that second part. All right, so we're still trending upward, so we still have a positive slope. That positive slope means positive velocity, which means we're going in the positive direction. All right, but this time we are going from more steep to less steep. So more steep to less steep means that we are slowing down. All right, more steep to less steep means that we're slowing down, but we're still going, we have that positive slope, so we're still going in that positive direction. Okay, so if I wanted to turn that into a velocity versus time graph, I would be above 0, that positive direction. Positive velocity means I am above 0, but I'm slowing down. So my line would be trending back towards 0. It would be trending back towards 0, so I would be slowing down. All right, so I have a negative slope, which means I have a negative acceleration. So it is a constant negative acceleration. All right, let's go to that third section, that segment C. All right, what do you notice? All right, this is a big part right here. So we go from a positive slope right here to a negative slope. So if we're going from a positive slope to a negative slope, that means at this point right here, we have changed our direction. We have changed our direction. All right, so now we have a negative slope. That means that we now have a negative velocity, which means we are going in the negative direction. Now that we know what direction we're going in, we kind of need to figure out what we're doing. All right, so we look at how the slope is changing. So we're going from a less steep slope to a more steep slope. So less steep to more steep does mean that we are speeding up. That negative slope does tell us that we're going in the negative direction. So we're speeding up in the negative direction. Now, that negative direction tells us that we're going to be below that x-axis on our velocity versus time graph. All right, so if it's speeding up, that means that our line will trend away from 0. So that's exactly what we see right here. Now, one big thing that I want you to see is this point right here. All right, it's not so easy to spot up here, but it should be like a beacon going off. Whenever you have something that crosses that x-axis on a velocity versus time graph, that means that it has gone from the positive direction to the negative direction. So that means that we have changed directions. All right, we have changed our direction at that point. All right, but another thing that I want you to see is that the line for this, I want to do it in another color. Sorry, all the colors, I know. All right, the line for this, we'll do it in red, is a constant line. It is a consistent line this whole way down. All right, so that tells us that this slope is a constant negative slope. So that's what we see right here. We see a negative acceleration at the same point as our negative acceleration was for that last point. All right, and then segment D. Segment D, we're just going to do it all in yellow this time. Okay, so we still have a negative slope. So that means that we have a negative velocity, which just means we're going in the negative direction. And we're going from more steep to less steep. More steep to less steep does mean that we are slowing down. So we're slowing down. That negative slope does mean that we're going in the negative direction. So if I wanted to do that or turn that into a velocity versus time graph, I would start with that negative direction. That means I am below that x-axis, and if I am slowing down, that means my line is trending toward 0. That line is trending toward 0. And that is a positive slope, which means that I have a positive acceleration, which is what you see right here. Okay? All right, so hopefully that is getting a little bit easier for you. Let's do a little bit of practice with it right here. All right, so we have 4 different segments, 4 different motions. In segment 1, we are still above 0, but our line is trending toward 0. So that should tell us that we are slowing down in the positive direction, slowing down in the positive direction. Segment 2, we are below 0, so that should tell us our direction, but our line is trending away from 0. So that means that we are speeding up in the negative direction. 3 is a horizontal line below 0. That means that we have a constant negative velocity happening, constant negative velocity. And then for segment 4, it's below 0 and the line is trending towards 0, which means I am slowing down in the negative direction. Okay, so if we look, we have a couple of questions over here. That first one is just asking, in which section of that velocity versus time graph is the object speeding up in the negative direction? Well, that is segment 2. It's in the negative direction, so it's below 0. Speeding up means it's going away from 0. All right, so that's what we see in negative 2. All right, the next thing that it asks us to do is to sketch an acceleration versus time graph for this motion. All right, so we're going to draw the full acceleration versus time graph because we do have both negative and positive slopes. So we have plus, 0, negative. All right, so we look at our first one. So if you notice, hopefully you are noticing right now that for segments 1 and 2, that is a constant line. That is a constant line. So even though it changes direction right there, it is a constant line. So that's a negative slope, which means we have a negative acceleration. So it is a constant negative acceleration for 1 and 2. All right, now segment 3, we've already stated, is a constant velocity. All right, that is a horizontal line. So there is no slope for a horizontal line, and there is no acceleration for something that has a constant velocity. And then last but not least, we see this upward diagonal line. So that's a positive slope. That means that we have positive acceleration. All right, and if we look at it, we can't tell 100% if it's going to be a steeper line compared to 1 and 2 because I don't necessarily have all of the times on here. But to me, that looks like it would be a little bit steeper. So we would just draw that a little bit further away from 0 than what our original slope was. All right, but it is still a constant positive motion. Okay. All right. Hopefully y'all are getting the hang of this. These are going to be our last different examples. We have already done these first two a lot. All right. So this one is showing constant velocity to the right. All right. So that blue dot means that that is where we are starting. We're moving to the right at constant velocity, which means that our data points would be equidistant apart. All right, so all of our dots would be equally spaced. All right, now if we're going to the right, that means that we're going in the positive direction, and that would be shown as a straight diagonal line in the positive direction with that positive slope. All right, now we know that the slope of a position versus time graph gives us velocity. So if we were to find the slope of this line, it would be positive. So that means that it would be above 0. And I'm not calculating it. I'm just going to put it somewhere above 0. But a constant velocity does look like a horizontal line above 0. All right, and then we know that the slope for a velocity versus time graph does give us acceleration. So if we were to find the slope of this, that gives us our acceleration for our acceleration versus time graph, but it's a horizontal line, and we know that the slope of a horizontal line is 0. All right, so we have no acceleration going on here. All right, this one is very similar. We have constant velocity, but this time it's to the left, which is in the negative direction. So that blue dot does mean that we're starting at the right, going towards the left. So our dots, yet again, are equally spaced. I'm doing the best I can. We're just going to go outside of that. All right, so they are equally spaced, but going in that negative direction. So if we were to graph this on a position versus time graph, it would just have that negative slope. It would be a straight diagonal line going in the negative direction. That means that the slope of this position versus time graph would give us our velocity, which is going to be negative. All right, but it does also mean a constant velocity. So we would see a straight horizontal line under 0 at somewhere. So if we solved for that, then that means that we would, I guess I could have solved it. It wouldn't have been that bad, like at 10. Okay, maybe that should have been 10. Sorry. All right, so it would be a straight horizontal line below 0 wherever we calculated it. And then we know that the slope of a velocity versus time graph gives us acceleration. Well, the slope of a horizontal line is 0. So we have no acceleration. There is no acceleration because we have constant velocity. No acceleration because we have constant velocity. But these two, the next two, are pretty cool. Okay, so we know we're going to have constant acceleration. So all that means is that we're not changing our acceleration. We are changing our velocity at a constant rate. And I know that I'm going to be slowing down. Now we need to figure out what is happening. So because this blue dot is starting on the left, that means it's going towards the right. So our velocity is positive, all right? It's going in that positive direction. But if I am slowing down, that means that our acceleration has to be going in the opposite direction. So our acceleration is going to be negative. All right, so if we are moving from left to right and we are slowing down, that means that our points are going to get closer and closer and closer together. I don't know why, but my dots also get smaller and smaller the closer they get. So if they're all supposed to be the same size, I apologize. But just go with me. It's fine. Everything's fine. Okay, so that is what it should look like. All of the dots should be the same size. That's just my brain does not think like that, apparently. All right, so if we are going in the positive direction, but we are slowing down, that means that we should still have a positive slope, but we're going from a more steep slope to a less steep slope. So what we would see on a position versus time graph would be a curve that looks something like that. Now, again, we still have a positive velocity, so it's going to be above that 0, but it's not going to be a horizontal line anymore. It's changing. All right, so it's going to be a diagonal. What we have to figure out is if it's going away from 0 or towards 0. Well, we know that it is slowing down, so that diagonal line is going to have to go towards 0 because it is slowing down. All right, now we know that the slope of a velocity versus time graph does give us acceleration. We have a constant negative slope. So if we were to solve this, all right, solve for it, let's see. My brain, I don't want to do it. All right, so we're just going to have a negative slope. It's going to be somewhere down here, wherever we calculate it. All right, so it would be a constant negative acceleration. So it's going to be a straight horizontal line wherever you calculated it to be below 0. Okay. Now this one, it's going to have constant rightward acceleration. So we know our acceleration is positive. All right, and then we're starting from the right and going left. So that means that our velocity is negative. All right, so we have opposing signs. So that means that I am slowing down in the negative direction. All right, so again, we're going to show that by our data points going from further apart, getting closer together. We'll see if I can keep my dots the same size. Can't make any promises. Okay. I mean, I started out okay. I didn't end okay. But that's what it looks like. It's going from right to left, and they're getting closer and closer together. All right, so we know we're going to have a negative slope because it's going in the negative direction, and it is slowing down. So that means we're going from a steeper slope to a less steep slope, which looks like that. Okay, so a more steep slope to a less steep slope trending downward. We have that negative slope. All right, so negative velocity means that our line is going to be below 0. We know it's not constant. We know that we have some type of acceleration, so it's not going to be a horizontal line underneath 0. It's either going to be a diagonal line going away from 0 or a diagonal line going towards 0. We know that we are slowing down, so that means that our line would be going towards 0. So it is a straight diagonal line going towards 0. All right, and this we have a positive slope, so that means that we are going to have some positive constant acceleration over there. All right, well, we're going to be doing a whole lot more practice on this, but if you have any questions, you know where to find me.